Chapter 8, Section 3, Glaciers. Glaciers form much of the landscape that exists presently in the northern United States and elsewhere in the world. Glaciers shape the landscape by eroding, transporting, and depositing huge volumes of rocks and sediments. Today, scientists measure the movements of glaciers and changes in their sizes to track climate changes. Air bubbles trapped deep in glacier ice can provide data about the composition of Earth's atmosphere at the time when these ancient ice layers were formed. Scientists can also study ice cores in glaciers to learn about Earth's environmental past, as shown in the problem-solving lab in this section. Moving masses of ice. A large moving mass of ice is called a glacier. Glaciers form near Earth's poles in the mountainous areas of high elevations. They currently cover only about 10% of Earth's surface, as shown in Figure 8.20. Even in the past, when glaciers were much more widespread than they were today, many areas of the world did not experience glacial activity. For example, during the Late Ice Age, which began about 1.6 million years ago and ended over 10,000 years ago, ice probably covered only about 30% of Earth. Areas of high latitude, such as Greenland and Antarctica, and areas of high elevation, such as the Alps, have cold temperatures year-round. Cold temperatures keep fallen snow from completely melting, and each year the snow that has not melted accumulates in an area called a snowfield. Thus, the total thickness of the snow layer increases as the years pass and a glacier begins to form. The weight of the top layers of snow eventually exerts enough downward pressure to force the accumulated snow below to recrystallize into ice. This recrystallization is familiar to you if you have ever made a snowball. Firmly compacting the snowball in your hands causes it to recrystallize or particularly melt or to form ice. A glacier can develop in any location that provides the necessary conditions. For example, small glaciers form even in the mountainous tropical areas along the equator, such as in Chile. Valley glaciers. Glaciers can be classified as one or two types, valley glaciers or continental glaciers, as shown in Figure 8.21 and 8.22. Glaciers that form in valleys and high mountainous areas are called valley glaciers. A valley glacier is shown in Figure 8.21. The movement of a valley glacier occurs when the growing ice mass becomes too heavy to maintain the rigid shape and begins to flow much like a thick liquid. For most valley glaciers, flow begins when the accumulation of snow and ice exceeds 20 meters in thickness. As a valley glacier moves, deep cracks in the surface of the ice called crevices can form. The speed of a valley glacier's movement is affected by the slope of the valley floor, the temperature and thickness of the ice, and the shape of the valley walls. The sides of the bottom of a valley glacier move more slowly than the middle because friction slows down the sides and bottoms, where the glacier comes in contact with the ground. Movement downslope is usually very slow, less than a few millimeters per day. You will learn more about the rates of glacier movements in the science and math features at the end of this chapter. As valley glaciers flow downslope, their powerful carving action widens V-shaped streams, valleys into U-shaped glacier valleys. Continental glaciers. Glaciers that cover broad continental-sized areas, such as the one shown in Figure 8.22, are called continental glaciers. They form under the same climatic conditions as valley glaciers, but they move in a different way. A continental glacier is thickest at its center. The weight of this thicker central region forces the rest of the glacier to flatten out in all directions. Continental glaciers are also called ice sheets, as much larger than valley glaciers. During periods in the past when Earth experienced colder average temperatures than it does today, continental glaciers covered huge portions of Earth's surface. Today's continental glaciers cover much smaller areas than they are confined to Greenland, northern Canada, and Antarctica. Glacial erosion. Of all erosional agents, glaciers are the most powerful because of their great size, weight, and density. When a valley glacier moves, it breaks off pieces of rock through a process called plucking. Fallen rocks also accumulate along the edges of glaciers and give the sides a striped appearance. When glaciers with embedded rocks move over bedrock valley walls, they act like the grains on a piece of sandpaper, grinding out parallel stretches into the bedrock, as shown in Figure 8.23. Small scratches called striations are larger ones called grooves. Scratches and grooves provide evidence of glacial history and established its direction of movement. Glacial erosion can create certain features as shown in figure 824. In addition to carving U-shaped valleys, valley glaciers also scoop out deep depressions called creeks, where two creeks on opposite sides of a valley meet. They form a sharp tree ridge called an arete. Where there are glaciers or three or more sides of a mountainous top, a steep pyramid-shaped peak forms. This is known as a horn. The most famous example of this feature in Switzerland, Matterhorn, a tributary valley that enters a U-shaped valley from high up a mountainside, is called a hanging valley. Glacial deposition. Glacial till is the mixed debris that glaciers carry embedded in their ice and on the top, slides, and front edges. When a glacier melts, glacial till is left behind. Ridges consisting of till deposited by glaciers are called moraines. Those at the foot of the large glaciers are called terminal moraines, shown in figure 825, and those at its sides are called lateral moraines. Where two glaciers join together, their lateral moraines combine to form a medial moraine. Outwash. When a glacier melts and begins to recede, meltwater floods the valley below. Meltwater contains gravel, sand, and fine silt formed from the grinding action of the glacier on underlying rock. When this sediment is deposited by meltwater, it is called outwash. The area of the land, the leading edge of the glacier, where the meltwater streams flow and deposit outwash, is called outwash plain. Drumlines and eskers. Glaciers that move more over older moraines form the material into elongated landforms called drumlines. Drumlins. A drumlin's steeper slope forces the direction from which the glacier came. Drumlin fields are found in Wisconsin, Massachusetts, and New York State, along winding ridges of layered sediments that are deposited by the streams flowing under a melting glacier are called eskers. Glacier lakes. Sometimes a large block of ice breaks off a glacier and is later covered by sediment. When the ice blocks melt, it leaves behind a depression called a kettle hole. After the ice blocks melts, the kettle hole fills with water from precipitation and runoff to form a kettle lake. Kettle lakes, such as the one shown in figure 826A, are common in New England, New York State, and Wisconsin. As shown in figure 826B, creeks also can fill with water and they become creek lakes. When a terminal moraine blocks off a valley, the valley fills with water to form a lake. Moraine-dammed lakes include the Great Lakes and the Finger Lakes of northern New York State, which are long and narrow. Mass movements, winds, and glaciers all contribute to the changing of Earth's surface. These processes constantly wear down landforms, and in many ways, they also impact human populations and activities.